Hi guys, welcome to Learn Electronics Repair. Today we have something rather special for you. We're going to take an in-depth look at how to make a schematic from a PCB. With me today is Datasheets, who's going to be assisting with today's video.
Hi guys.
So let's just discuss what we're actually going to do. This is actually a PCB, it's a power supply. And this is the guinea pig we're going to use in today's video. Now, just before we start, let's talk about what we want to achieve here, because there are a few different things we may want to do, and this process is actually going to work for all of them with some slight differences. So basically, using what we're going to show you today, you can make a copy of this PCB to produce a copy for yourself. You could create a schematic from this PCB if you want to modify the circuit, or if you just want to understand better how it works, maybe to repair it. Or you may want to do both. Alternatively, you may want to make another version of this PCB. For example, you may want to make a surface mount version rather than a through-hole version. So all of these things can be done using the techniques we're going to show you today. So to start, let's just look at the equipment we're going to need. And actually this is very basic. So we need something to take a photograph of the PCB. Mobile phone is perfect, or a camera, whatever you have, but something as simple as your mobile phone is just fine. The other thing you need is a multimeter. It doesn't have to be anything special. All you're going to use a multimeter for is to see sometimes where one track is connecting to another if it's not obvious just by looking at it. So that's the hardware we need, nothing more. We need a little bit of software, but the software we're going to use today is all totally free to use, free of charge. So I'll pass you over to Detlef now, and he's going to talk a little bit about the software. Today's video was sponsored by PCBWay, who manufacture bespoke PCBs. PCBWay is an ideal partner for hobbyists and also for companies and individuals who want to manufacture PCBs, prototype their designs, and you can order a small number of PCBs very inexpensively if you're working on a design, or take advantage of PCBWay's other options such as multi-layer boards, flexible boards, pre-assembled boards, and other similar services. I have here a selection of PCBs from PCBWay. Let's have a quick look at them. You can ask for PCBWay to manufacture your circuit boards in a variety of colours and styles. You can see we have some here with rounded corners, which is an option we have, different coloured masks, different coloured silk screens. We have boards with square edges, and to be quite honest, you can actually have bespoke boards made to any shape or design. You can order single-sided boards like this one, or double-sided boards. The cost is the same for the two. And you can order PCBs in various styles, such as these ones. You see, these have my channel logo on and Retro Upgrade. This is a project we worked on. This also has the gold finish on it, so this one's gold and black and gold and red. So really guys, the choice of options are almost endless. Ordering PCBs from PCBWay is very simple actually. So we go to PCBWay.com, and here we have an option saying instant quote. So we click on quote now, and on the next page we can go to quick order PCB. We click this, and now all we need to do is add a Gerber file. We don't need to change any of the other options if we don't wish. We just add a Gerber file. Here is one I have. Open, and the software on the web page will analyze the file. You can see there an image of your PCB, and now you can choose various options if you wish, or you can just order. For example, the color of this channel is red in the logo, so I like to have red PCBs. And here we see the costs. So for 5 PCBs to this design, you can see the cost is $5 for 5, that's $1 each. And there are various postage options. So we have a global standard of US dollars 386 here to Spain, which is my country. But you can choose all the other countries on here which support it, they ship worldwide, and you can choose many different shipping options. So if you want these things urgently, 3 to 5 business days, for example, you could use DHL or FedEx, a little bit cheaper, 1 day slower. I'm going to use the most economical option because I don't need the boards very quickly, which is global standard shipping. Apply that, and you can see the total is $8.86 for my 5 PCBs. This is the shipment date, 18th of April. It's now the 14th of April. We have the weekend in between. And there is the delivery date, 29th of April. Okay, 9 to 13 business days to Spain. If you're happy with the quotation, you place your order. PCBWay will then check your design to make sure there are no production problems. Only after they've checked the design, they're happy they can produce them to your specification, will they ask for payment. Once you make payment, the boards go directly into production. So you can see PCBWay have a very easy to use service. If you've never ordered PCBs before, it's literally as simple as I have just shown you. So give it a go, guys. Upload your Gerber files, order your PCBs, and I'm sure you'll be very happy with the quality of the boards that you receive.
Well, thank you, Richard, man.
Oh, you're welcome.
Yeah, it's great fun to be here. And yeah, we were thinking a lot about how could we do this the easiest way, the most ghetto way, and even without paid software. Nobody wants to pay for Adobe software. And yeah, we were looking around. We were looking at GIMP. We were looking at Critter, something. Yeah, they're all fine, but I have a different thing here because I really like this, and this is probably because I'm from Photoshop, you know that. And this is something that feels like Photoshop, and it runs in a browser. This is Photopia, Photopia,
or even Photopia.
Could be Photopia.
However you pronounce it.
Yeah. Whatever you want to pronounce it. We won't do a lot of this because we don't need to do a lot of it. But this is a free software. It runs in your browser. You don't have to download anything. You don't have to install gigabytes of software. This simply runs in your browser.
Excellent.
And you don't need an account. We do this without an account. This is just free. And you see all the nice commercials we get over here.
Okay. So this is the price of anonymity.
It is, yeah, but it doesn't hurt us.
Okay.
And before you ask, you don't need a gigabit internet line for that. I tried this on a 25 megabit line and it worked fine. They do so much in the browser now.
Excellent.
It's crazy.
Excellent. Okay.
Yeah.
That's the photo editing software.
That's the photo editor for
what
us.
What else are we going to use?
Oh, not much more, because we only need an EDA software.
Okay.
And you probably remember that we used Easy EDA the last time we did that. Now, this time we're going to use KiCad. KiCad, probably everybody out there will know KiCad. This is also open source, free software. We have to bend some rules here because this was never intended the way we were going to use it. Because normally you go from a schematic to a PCB, and we will do this the other way around. We think KiCad is the best way to do this, probably better than Easy EDA, even if it looks like it's for Windows 95 build. Sorry. Yeah, we didn't go for the commercial route here, so Altium is out, Eagle is out too.
Okay.
So this was the reason why we used KiCad for that one.
But I think, considering this is free software, and it does seem quite capable of being used in this way, as we have found, we have played around a little bit with this, I think you guys will agree this is the best way to go. So the first thing we need to do is take a photo of the PCB. Simply use your mobile phone. Don't worry too much about reflections and such like on there, but try and get an even colour. If you see any severe reflections, try taking the photo from a slight angle. It doesn't matter if the image comes out a little bit distorted, because with Photopia, or whatever else it's called, Photopia, it will easily allow you to fix that. Let Det show you how to do it. Just before we edit the photos that we've taken of the PCB, and as in accordance to all good YouTube video making, I forgot one step, and I also forgot one tool that we require.
Very important.
And that one is a ruler. So it's important that we get the dimensions of the PCB. Otherwise, the footprints of the components will not fit on the board. It doesn't have to be to within a micron. Within a millimeter is good enough, really. So we can see that this board is 75 mil high, if we want to call that a height, and it is 156 6Y.
Okay, guys, back in the magical world of Photopia.
Photopia.
Yeah, this will follow us.
Forever.
Forever.
You guys will tell us what this is called,
Yeah, please make a decision how we should call it.
Okay.
Yeah. All right. Let's go for the easy way. Okay, we'll simply open the image. We took some images before. We didn't show you how to take an image with your phone, so we thought you probably know how to do that and to move the image over to the computer, so we skipped that part.
And if you don't know, comments below, guys.
Indeed. All right. We just selected this one as a image for us. So let's see. And you see, we didn't put any work in this. We simply took a skewed image here and we said we fix the rest in post.
I think that was mostly because with the phone directly above, I was getting reflections. Oh, and when you do take the photos, guys, turn the flash off on your phone.
Oh, yeah, that's a great tip. Yeah, that's a great tip because it will burn everything out.
Yeah.
One thing, if you have access to a flatbed scanner, a flatbed scanner would be the best way to take this image because it's flat already and it always has the right size. All right, what do we do first? I think we have to flip the board, I think.
Yes, because this is a mirror image of the PCB. So if we try to place our components on this, for example, the IC, all the pins will be in the wrong positions.
Indeed, yep. So, and we have to look from there, from your side, through the board to do the...
Basically, that side.
That way, yeah.
Okay.
So, okay, if you want to do this now, you will find you can't do anything because backgrounds in Photoshop and in Photopia is always locked. So I'm going to make a copy of the background layer. Simply, I grab the layer over here and drew it onto the second symbol to the right. This is a new symbol. And now I have a freestanding layer over here.
Okay.
What I'm going to do now, I'm going for Control, Alt, and T. This is a transform command. And the first thing I can do in here, I can go for flip horizontally. So
okay. Yes.
And there we are. So now we have a mirror image of the whole shebang. And it's a good starting point, I think.
Yes.
If we want to scale the image right now, we have to do this in a way that we keep the proportions of the original PCB Richard just measured.
Okay.
To do that, I'll simply define a square frame. This is not square.
We'll call it a box.
A quarter box. And you see we already put in the 156 and the
75.
How much precision do you need here? If you're going for a schematic, you're probably fine with the ballpark. So if it's 75 or 76 or 74, it doesn't matter. If you want to recreate the PCB, say you have a power supply for an old computer, then you want to be precise here.
Yeah.
All right. After I did this, now I can draw a rectangular over here. You see, I can do this. And these are the proportions of the PCB laying over there. This is the thing in which we have to put the image into.
Okay.
I'm going to crop this now. I simply can go for crop.
Okay.
As you see now, it turns into a crop field. And then I say, okay. So these are the proportions. Not the size, but only the proportions of the image we're going to need in KiCad.
Really then like the aspect ratio?
The aspect ratio.
Okay.
Thank you very much, sir. All right. Okay, I'm going to transform this now. So Control, Alt, and T again. And if I click on the corners here, you see, okay, I can only scale it. This is not proportional. I can't distort it. I need to hold Control for that. If I hold Control, I can go for this, and now you see there's some movement over here.
So you can stretch each corner.
I can stretch it, and I'm going to fit this into the frame we just did.
As close as possible, I guess.
As close as possible, yeah.
Okay.
Again, ballpark. If you're going for a schematic, this is something where you simply go, okay, just let it fit somehow.
Okay, so now we just align the remaining corners.
Indeed, we do.
So holding down the Control key while you're pressing the left mouse button and dragging the mouse. Okay.
So
and I see it slightly interact, so you're having to readjust the other corner slightly.
Indeed, because this is all interconnected, and if you move one, the other will move too a bit.
Okay.
Again, precision is just what you want to have.
Okay.
This looks pretty much okay for me.
So what can we do with the image? Can we highlight the tracks more and darken the substrate?
That would be a good idea here.
Okay.
Because we're in a photo editor, so everything that makes it better to read for you, do it now.
Okay.
So personal preferences, I'll go for the effects layer here and go for curves. And you see, this is the representation of the image. This side is black, here's the middle grays, and this is the bright areas.
Okay.
And you see there's a lot of dark stuff in here, a bit in the middle and less of the brighter stuff.
Okay.
And if I just click in here and drop a point in here, you can see now the brighter stuff gets brighter, German. And the darker stuff gets darker if I put a point in here and draws this down. So this is a contrast.
Okay.
This isn't a photo. This is not something that, of course, this is a photo, but it isn't something that goes into a magazine, something.
Yeah.
So you only need to look for when it's good for me.
Okay.
Are you okay with that?
Yeah, it was good to me.
All right. So let's say file, and there's a save more feature. No, it's an export. And I can export as a JPEG.
Okay.
And I call this one, say,
Test. Okay.
Let's call it test JPEG. Will be stored somewhere in my downloads folder, I think, because it's a browser.
Yes.
Yeah, and it saves. Yeah, and it saved it over that.
Okay, so have we now finished with Photo P?
I think Photo P is done now. Yeah.
Okay, then let's look at KiCad next.
Okay, let's get over there.
So this is KiCad, and the first thing we're going to do is open a new project, or rather create a new project. So new project, and we will give it a name, something like LER. Okay. Save. We now have a project, and automatically KiCad has created for us a PCB layout page and a schematic. Double click on the PCB layout, and there we have our blank sheet. Now, the first thing we want to do here is import the image that we just created. And as Detlef created it, I'll let him show you how to import it.
So right, to import an image, you go over to the Tools palette, and there's this icon for Add Bitmap Image. So we're going to go there.
Okay, so here are our images.
There are the images, and I'll simply open the test file. This is the thing we just saved from Photo P.
That's one. Okay.
Now I have to click to
and it's huge.
This is ginormous. Yeah, you see the outline over here. So I bring it down a bit. It doesn't have to be that big. Yeah. So all the scrolling is done with the mouse wheel. So if you want to scroll in and do something, just use a mouse wheel.
Okay.
All right. Now we have this image, but we have no proportion. How big is this?
Yeah.
Of course, we could measure it. This would be one thing, but we found an easier way. We simply go for a footprint. This is the thing over here. And then we go for dual inline package.
Yeah.
And I go for the standard dip 8 without anything hanging from the sides.
Okay.
And then I try how good does it fit onto my dip 8. I know there's a dip 8 on this PCB.
Yeah.
And I simply try to see how good the pads fit together.
And they're very close.
This is very close. It could be a bit, the image could be a bit bigger.
Yeah.
Let's try this. I simply drop it here. And if I now click with the select tool, now click with the thing, the image gets to the front, so you don't see your footprint right now.
But it's still there.
It's still there. It's just behind the image. And now I can rescale it a bit, just a tad. Move in again. See how good this fits.
So basically you're fitting the circles with the numbers in over the actual pins we can see.
Indeed,
on the board. Yeah. And in actual fact, the image wants to be a little bit bigger again.
This is nearly there, but not quite. Just a bit more. Get in again. Select this.
And that's getting very close now.
I think that's it.
That's it, yeah. Okay, so this step, guys, if you wanted to recreate this PCB, to clone it, then this is very important to get the size right. Once we've done it with one component with this sort of footprint, which we know exactly what size it's going to be, then we don't have to do it for any other components as replace them. If you are just wanting to make a schematic, although you don't need to do this step, we found it's easier to do it anyway because it helps when you actually are trying to draw out your traces for you to see where the pads are actually connected to other components. Now we're going to add the components onto the PCB layout to start creating our schematic. We're just going to add a few components on this video at the moment just to show you, give you the idea of how to do this. We're not going to do all of them as this is quite a time-consuming job. It's not difficult, but it does take a bit of time. So we'll show you with a few components and then we can move on with one we've already partially populated. Okay, so we're going to add a few of the resistors. We're going to add a few capacitors, a few inductors, and then we're going to explain how to deal with things like this choke, which effectively is 2 coils, and the transformer. Okay, so let's go back over to KiCad. In KiCad, you can see at the bottom here, we actually have the project open and we have the PCB open. We now want to open the schematic. So to open the schematic editor, we just click on it, double click, and it's open. We now have a blank schematic sheet. Det, can you show us how to add some components to this?
I think I can.
Okay.
This is pretty easy. You go for the operational amplifier over here. This is add a symbol, or press A, just like it says in the brackets over there. Then it loads up this thing, and yeah, there are 19,000 items. You can have a really fun time scrolling through all of them.
Okay.
Or you simply go for the standard things. Resistor is an R.
Okay.
So you simply type R on your keyboard, and you get thrown to the resistor. So now I double click here, and I have my resistor over here.
Okay.
That's all fine. That's all fine. The problem is right now, there's no footprint associated with the symbol.
Okay.
And this is the first thing we should do right now.
Okay.
Because we want to have a footprint for that.
Okay.
The symbol is for the schematic editor, and the footprint is the thing that goes onto the PCB.
Okay.
So right now I go for a right click and go for properties, or I simply click E.
Okay.
And you see there's no footprint connected here. So right now KiCad doesn't know what this resistor will be in real life.
By footprint really means that KiCad does not know what size this component is, how many pins it has, and the location of the pins, the arrangement.
Yeah. And it doesn't know if it's an SMT component or it's a through component. This is all not defined right now.
Okay.
What we're going to do now, we're going for footprint. And you see this symbol here, this is a library symbol.
Okay.
So, and then you get thrown into this long list. Resistors, through-hole, resistors, SMT. So, I simply grab one, and you see this is the footprint for that. And yeah, if you're looking for a K button, there's none. You have to know that you have to double click this.
Okay.
This is what I meant with very bad interface design.
Mm-hmm.
So now this thing pops up over here. So this is a resistor I just chosen, and I go for OK. And now this symbol has a footprint. This is how you connect the symbol with a footprint in KiCad.
Okay, so we're going to add 2 resistors. We're going to add R2 as well. Can we just duplicate the one we have there and change it to R2?
That was why I wanted to connect the footprint right now. So I simply can grab R1, do a Control-C and a Control-V.
Ah, and it's automatically R2 now. Okay.
And it has the footprint in there.
Okay.
If I select it and go for E, just like properties.
Okay.
You see there's a footprint we already selected in here.
Okay.
So we now know we have 2 resistors with the same footprint in here. And what we do now, we simply count how many resistors are on there and simply throw in that much resistors.
Yeah, sure. And I assume where it says R, we could change that name to show the value of the resistor if we wanted to.
Indeed.
So we'll just add a couple of more components, which are capacitors, 2 of these. We'll do the same now, you'll see that. And then let's see how we can place these on our PCB. Okay, so we have 2 resistors. Now we're going to add some capacitors. We'll just add 3 of them. So we're going to add this capacitor, which you can see as an electrolytic. We're going to add C2, which is this one. And we're going to add C3, which is this one. Okay, back over to you, Det.
All right. Okay, the first thing we're going to throw on here is the electrolytic. So I go for the symbol here over here and go for C like capacitor.
Okay.
Scroll down to C for capacitor.
Ah, and this is the unpolarized capacitor.
This is unpolarized indeed.
Okay. Can we use this then as C2 and C3 and come back and do C1?
We do that.
Okay.
We do that, yeah. So I keep this in mind because I already have it in here. And remember, there's no footprint on this one. So I'll just keep it there and don't start to copy it right now.
Okay. And we just want to rename that to C2.
Indeed.
Okay, how do we do that?
So I'll select the symbol, press E for preferences.
Yeah, and change the reference there to C2.
C2. And
okay.
Here we go. Okay.
And we have C2. Is this how we add a value as well? For example,
Indeed.
Okay, so this capacitor, I can tell you, is 10 nanofarads.
Okay, 10 NF.
Okay.
There you go. And it displays it over here.
Perfect, perfect.
Yeah.
Okay, so now we need to add C1, which is the electrolytic.
Let's go for that. So now let's add a polarized capacitor over here.
Okay.
So, and the keyword is polar. So then you get a C polarized capacitor, and you see over here, it has a plus and a minus. So we can add this one here, C polarized, and this is going to be our C1.
Okay.
I simply select it here, go for E for preferences, and can you tell me the value?
The value is 82 microfarad.
82?
82 microfarad, 450 volts.
450 watts.
Okay.
So, okay.
Nice.
Nice. So let's add some footprints to the capacitors. For C1, we need something like, oh, this is going to be hard.
Well, it's actually a radial one, so the legs are not too far apart. So I think I'll just choose something from a capacitor.
Yeah. Can you measure the pin width?
I can. It is about 9 millimeters.
All right. I think we go the easy way here because we'll never have a fitting capacitor here. So I go for capacitor through hole and radial 18 millimeters by 75.
10 is close enough, probably.
Oh, look at this.
Okay.
I can live with that.
I can live with that too.
Yeah. So we'll throw in something like this here and we can change it later.
Of course.
Remember, no OK button, double click, and then simply press OK.
Okay, and we'd have a footprint for that one.
Now there's a footprint. And C2, we can go for discs. Load it down here, there are the discs. So 7.5, something like that. These footprints are pretty generic. This could be a resistor too.
Okay.
So remember, double click and simply go for OK. So C2 we have over here, and we probably have a C3 on that one too.
And it automatically went to C3.
Can you tell me the value of this?
Yes, the value of this one is the same.
The same. So this was pretty easy. Now we have our capacitors.
And resistors. So let's now update our PCB and place these on the image of the PCB that we have.
All right, let's do this.
There may be some different ways of doing this, guys, but personally the way I do it is I go to Tools and then I choose Update PCB from Schematic. Okay, it's done that. Update PCB. Close. And you can see we now have our components on the PCB. We just need to place them somewhere out of the way and then we can drag them to where they belong. I'll actually make the picture a bit bigger to do this, and we should be able to see marked on the PCB the actual components. So for example, we have R2. I'll just click on the arrow, select R2, I have it, and I can now drag this to the correct position on the board. Okay, R2 goes somewhere in this area. We can have a look. Actually, guys, it goes near the top. You can see it there as a mirror, R2, okay? So we can just grab our resistor and we can bring it up here. To rotate it, we just press R. And you can see that it's actually much smaller than the footprint. You can see the two legs there and there. Now, if we just want to make a schematic, I could drop this somewhere here. I can see which tracks it belongs to. But if you want to make it more accurate, you just need to change the footprint. So to do that, we right click and we go to change footprint. Now this brings us a rather strange requester, but we want the new footprint library ID, which is this one. And we can see our footprint was 5 millimeters and we did it much bigger. Let's go say to 15 millimeters. Okay, so I've chosen the footprint, but at the moment it hasn't changed anything. It's still the same size. We hit change. We then hit close, and now you can see our resistor actually fits on the board. If we just want to move it slightly, we just drag around it to select it, and I can now position that on the pins. And I can do the same for R1. So for example, R1 is here. Okay, I'll just select the component by clicking on it. And now I can drag this down. We can see R1 is here. R to rotate it. Now you'll notice that when I change the footprint for one of them, it's actually changed it for both of them. and that fits nicely on our board for R1. Okay, so I've now positioned the capacitors. I can zoom in. You'll see that C1 fits quite nicely. We could choose other footprints, but that, if you look, fits pretty much on the legs. We could certainly make a PCB and put a capacitor in there. C3 fits a little bit small, if you like. And we can look at C2. Now, C2 is much bigger than we should have. So let's just try to change one of these, but now we're just going to change just this component and not all the other capacitors. So again, we right click and we go to change footprint, and you'll see we have some options here now. So change footprints with library ID, that will change all the components with that footprint to the new one. We can also, for example, choose to change footprints that are capacitors or which are a certain value, or we can just change the selected one. So I'm now going to change selected, and we're going to make this one quite a bit smaller. Again, we can really do this by trial and error. We can just choose a size, double click, we can change, close, and we can see. That now is too small, so it's just a matter of trying a few times until you get the footprint you want. As we mentioned before, if we just want to make a schematic, this isn't really important. As long as we can place the component something like this, we can see clearly that it connects one end to this track and one end to this track. That's all we need. You only really need to resize these accurately if you want to recreate this PCB. Let's have another go at this one anyway. So change footprint, only the selected item, choose something a little bit bigger, show us here what size it is, 2.6, 250. So we can go for something a little bit bigger, 6.5 say for example. Maybe that's a bit too big. Let's go for this one. I can already see the updated footprint. It is much too big. Let's go again. It's showing the one we already have, so we can go for another one. Change. That looks about right to me. It's good enough for what I want to do. So we go close this, and we can now just move it. Okay guys, so that's how you effectively place resistor and capacitors. Now we'll just show you a couple of the more tricky components. Okay, so we're back to the PCB. One thing I didn't check is if I have this capacitor, the polarity the right way around. We'll show you how to fix that if it's the wrong way. We're now going to add some inductors. So we can see we have here some inductor beads. For those, we simply just choose an inductor like we were doing with the capacitors and resistors. But we have things like this choke. Now, it may be difficult to find a footprint for this and also for this one. So what I suggest you do is to effectively consider this to be two inductors. Now, this component is called LF1. That's its designation on the board, LF1. So we will effectively make two inductors, LF1A and LF1B. Okay? And for the transformer, if we have a look, you will see this has 3 coils. Now, one is a secondary here. So this is one coil, and we have 2 more. Now, these are 2 separate coils. The easiest way to figure this out is to use a multimeter if you're not sure. So we'll take the multimeter. I did say you would need this at some point. And we can see this coil will read like a short. Okay, there's another coil here which goes to there, but it doesn't go to here or here, and there's one here. Okay, so we have 1, 2, 3 coils. This one is actually the primary. That's a little bit of my knowledge because it comes from the positive output of the bridge rectifier, but you don't need to know that. But because I do know that, we're going to call these 3 inductor coils by a meaningful name. So this transformer, in fact it says primary, secondary, we can see which is which. This is called T1. So we're going to call the first inductor T1P for primary. And then this is 1 secondary, so we can call it T1S1 and T1S2. You may find when you're doing this that you have to name the component with a number at the end. It may not allow us to call this T1P, so we could call it T1P1. And the same with these. These could be LF LF12, or LF1A, 1, 2, however, yeah? So let's create these components just using some inductors.
So back into the editor, we're going for the schematic editor here because we're still putting together all our components. So add a symbol, and the symbol starts this time with an L for inductor, of course. So this is a simple inductor, and I start here by simply dropping it over here and giving it a name. I think the naming is the important part here because you don't want to mess this up. So the first one we're going to call, what was it, Richard?
LF1A.
LF1A.
You have two L's.
Oh, I have two L. Yeah. LF1A.
Okay.
So this will be our first inductor. This is a choke. Let's see if this works. And
Yes,
it works.
it does.
LF1A is okay. Go for edit and select the footprint. You have an idea how about
They are about, roughly speaking, 1 centimeter, 10 millimeter.
10 mil. Okay.
I can see one that looks like a 10 millimeter
It is, yeah.
here or here, yeah.
Yeah. Oh, this looks nice.
Okay.
I'm fine with that. Something Murata, something. For me, it's just only important that the pitch P,
Yeah.
this part, that this fits somewhere there.
Okay.
And remember, no OK button, just a double click and OK. So if I copy it now, copy V,
Okay.
and change the naming to LF1B.
Okay.
So right now we need a transformer.
Which is going to be 3 more inductors. So we need to make 3 inductors. Now the pitch on these, one of them is different, okay?
Of course it is.
Of course it is. So the first one will be T1P, which is a primary.
Let's see. T1 primary.
Okay.
Let's see if it's okay with that. I'll simply leave the footprint in here and we'll change this later.
Okay. Well, actually, the primary, I can tell you, is, let's see. The primary is about 10 mil.
10 mil. Okay, that would fit.
The 2 secondaries are about 6 mil. 5 or 6.
So I'll have a secondary. T1
S1, first secondary.
S1. Okay, and I have a second one of those.
Yeah.
And the naming should be right, okay.
T1 S2.
All right. And one of them has a different pitch.
Both the secondaries are the same, and they are about 6 millimeters.
6 mil, okay. Let's see if we find something. I have a 7.7.
Yeah, it's close enough, I think.
Yeah, good enough for Australia.
Okay.
So let's use
Okay.
this. Okay. And use this and 7 point something. Go there.
0.62.
something.
Okay, fine.
Okay. So now we have all the inductors in here, but we don't have them on our PCB. So
Okay.
Rich just did it by Tools Update PCB, or you simply press F8.
Okay.
Remember that to have selected this window. This
Okay.
window is important, and I press F8 now. It just tells me updating blah 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 blah, and
Okay.
I'm going for that and go.
And we now have them.
So here are my 5 inductors I just placed.
Okay.
So
I think it's easier now to maximize this window.
You're right. Let's do this.
Okay, now we can see.
Yeah.
So we have LF1A and LF1B are the 2 parts of the filter inductor. Yes, exactly where you were showing. So that's where we put those 2.
Let's move them.
Okay.
So grab the first one. I'll rotate this before I move it and simply shift it over here and
It fits
let
nicely.
it fall. And use the other one. Rotate
Okay.
and drop it over here. So now comes the rather constructed part of the transformer.
Okay.
So,
So the primary is
this is a primary.
okay.
I can grab you. You won't escape me.
Okay. No escape.
No escape.
And you see, guys, because I measured them, they are basically the right size.
Yeah.
This is one of the secondaries.
So
That's a little bit big.
that is a big bit. For our purpose, this would be fine because we simply drop it here and we know that there's a connection. Okay, and the secondary over here goes somewhere over here, I think.
Yes, there are many pins,
Yeah.
but it fits between those 2 tracks.
Yeah, we simply drop it over here because we know that it's going to be there. And for our intents and purposes, drawing a schematic, this doesn't matter.
Okay. While we're here, let's just check the capacitor, the electrolytic,
Oh yeah.
that we have it the correct way round, and in fact we don't have, I think.
Yeah, this is the wrong way around. You're right.
Okay.
So rotate, and then I move it over here.
It's actually marked plus on the PCB.
Indeed it is.
On the image, so best to do that now, guys, before you explode it.
Indeed.
Okay.
Yeah, this is going to be loud. And it smells bad.
Oh, exactly. You can tell there was prior experience here, guys, and that sort of thing. Okay, so what we will do now is we'll just show you how to add the IC. Now, we know the package fits on, so the image is the right size. But what we want to do is create an IC for our schematic that has the correct pin out. Now, the one that's on our board does not exist in the library. So we'll show you now how to create a schematic symbol for this IC using the datasheet. So this is the datasheet for the pulse width modulator controller for our power supply. This is the part number. And if we have a look at the datasheet, we'll find some useful information. So firstly, here is a typical application, and secondly, we have the pin out here. So we can see the names of the pins. I'm just going to make a note of them. And the other useful information here is the typical application. So we can see a diagrammatical representation of the chip here in the circuit, typical circuit. Our circuit is probably going to be very similar to this one. So if we create a symbol in the schematic with the pins placed around like they are here, the chances are it will work very well for our schematic. Okay, so we need that information to create the actual symbol in the schematic, and we need this information to create the actual footprint.
Okay, to create a symbol, not a footprint, a symbol, we need to get out of the schematics editor. I simply scale it down a bit. And you see over here, there's a symbol editor in your KiCad main dialog. So open the symbol editor. And there you find, an empty sheet. That's fine, because this is where we want to start. The first thing I have to do, I have to create a new symbol.
Okay.
No symbol library selected, so I have to select the symbol library first. And since we're doing this from scratch, and this is the first thing we do this here, we create a new library and call it something like
test.
Test something.
Okay.
Something. We go for test. Save it. So now we have a library, and now we need a new symbol for that. So the symbol name would be IC
E3BR
0665.
That one.
That would be our symbol for that. And the reference designator would be, we call it IC.
Certainly on the board it's called IC1.
So I go for OK. And now I have a very big IC over here.
Okay.
And what do I do now? I want to place pads. Because we know we have pins over there. And we're going to need pin name. The first name was...
The first pin name was BA.
So let's call it BA and...
Pin number 1.
Assign it pin number 1. We have no clue what the actual function of the pin is, so I go for unspecified in here, graphic style, line, stuff, and simply go for OK. So now I have a pin 1, it's called BA, and I'm going to do this for all the 8 pins right now. And you know me, I'm a lazy guy, I simply copy them.
Okay.
So copy and go for FB, like feedback, and this is pin 2. Okay. And you're going to see why it's important to keep the numbers in here.
Okay.
V and E.
This is chip select, so yes.
Yes. And this is pin 3.
Okay.
Control V.
This is drain, pin 4.
This is drain, and it's number 4. And this is an easy copy because pin 5 is drain 2.
Correct.
E, and this is pin 5. Control V. This is pin 6.
Now pin 6 is no connection.
Yeah, we'll keep it in here because it's there, and
NC,
and I don't want to risk that it's...
Do we change the electrical type from unspecified to no connection? Is there
a no connection? Let's see. I never checked.
Unconnected.
Unconnected. Yes, that's a good one.
Okay.
Yeah. And this is good because it already tells us, okay, there's no connection possible here.
Okay.
So this is a fail-safe.
Okay.
And
2 more.
Number 7. Lucky number 7
is VCC.
VCC. Or no. It's go the right way here.
Right.
And this is pin 7. And I'm running out of screen space here.
Okay.
And number 8
Is ground.
GND.
Okay.
Number 8.
Okay.
All right, now we have all the pins lying around. And in fact, this would be enough. We could leave it like that, but the symbol should look a bit like a symbol, I think.
Yeah.
So let's draw a rectangle, because all the symbols look somewhat like a rectangle.
Okay.
And now I simply put the pins on that. So we can go something like it's in the schematic. So we have a semblance here.
Okay.
So let's do this. So I remember that VCC is somewhere on the top.
Yes.
Oh, come on, VCC, follow me. No, just VCC, please. Thank you. So rotate. And I'll put it somewhere over here. Guys, remember, this is a point where the wire connects later.
Okay.
So this must be pointing somewhere out there.
Yeah.
Because otherwise you have all your connections running into the chip here.
Okay.
Not that this happened
That's
to me.
fine.
And
No,
no, would never happen.
And it'll never happen to you guys now for sure.
No. This has never happened to anybody.
Okay. So
Ground goes somewhere over here. So
yes.
And since we have not connected lying around, not connected, I think isn't in the original symbol, so I'll
Nope.
simply let it lie around somewhere there.
Okay.
I have 2 drains here. You want to have them somewhere over here? on
Yep.
the right?
Somewhere to the top of that side.
Yeah. All right, let's move it over here.
Okay. Then the next one down is chip select,
All right, let's go for chip select.
and then we have feedback,
Feedback is
and then we have BA.
BA.
Now you're dragging those the wrong way, aren't you? Aren't you putting the little circles on the edge of the chip rather than at the end of the wire?
You are right, my friend.
Okay.
So, let's shift them around.
Yeah.
Never happens, as I said. But I think a chip select should be on top, right?
Yeah, chip select at the top,
Yeah.
and then FB, then BA.
Yeah. All right.
Okay.
No.
Okay. And then chip select at the top.
Yeah. All right. So
We have the symbol of our
we have
chip.
a symbol. We have a symbol. Yeah.
And looking like the data sheet
Yeah. It looks
Typical-
like a data sheet.
layouts. Can we put that letter IC in the middle of it, or does it have to be outside of it?
Yeah. Okay, we can do that.
Yeah, we can name it
Yeah. Save some
IC1,
space,
IC2.
yeah.
Yeah, okay.
Save some space. Yeah. All right. You notice that we don't have a footprint. This is just a symbol. This is not a footprint.
Okay.
And we're going to show you how to connect the footprint to this symbol right now.
Okay.
So if you're wondering where the symbol is right now, you just go for your symbols. And since we saved it in a library that we call test, so just type test over here. There's my test library.
Uh-huh.
And there's my chip.
Okay.
And this is my symbol that I just drawn.
Okay.
And you see there's no footprints specified. I simply go for OK for now. So here's my chip.
Okay.
And right now I can go for just type E for preferences. And you see there's a footprint again.
Okay.
And if I open this and I go for packages dip,
Yep.
dual inline packages.
Okay.
Right?
And then dip HW7.62, which is a standard.
I think so, yeah.
Yep, that's it.
That should be, yeah. And now something really interesting happens.
Ah,
If you look at the pins, you see BA, FB, CS,
Yes.
drain, something. All the pins that we referenced in the symbol are already mapped over here onto this footprint. So you don't have to think about that anymore because it's already there.
excellent.
That's really good, yeah. And that's the big point for this one, because I said somewhere at the beginning that you don't have to know what kind of footprint you want to use. If this chip is available in SMD and the pinout is the same, you simply throw in a different footprint for an SMD type,
Yeah.
and you're done.
Okay. So do we need to double click to save that or something
Yep.
now?
Double click this and simply say OK, and there's your chip. Box and anchor.
So we should be able to add that to our PCB now.
Let's do this.
Okay.
And again, to update the PCB now, just simply select this window, press F8, and 2 times return, and there's my chip.
Okay.
Move this over here.
And that will fit nicely because we already sized the image.
We did.
Oh, that's good, Det.
That looks really nice. So,
Okay.
there's our chip here. And that's how you do the connection between a symbol and a footprint in KiCad.
So now we know quite a lot about reverse engineering the PCB. We know how to take the photographs with just a mobile phone, how to manipulate the image to get it square as you require, how to resize the image so it fits the footprint of the components, how to place components on the actual tracks of the board, and also add components to the schematic. For trickier components, we have some ideas how to go about it, including how to use a component datasheet to design your own symbol. Okay, so that is the end of part 1. There's plenty of things there for you to play with. Within the next week, you will see part 2. In part 2, we're going to talk about nets, what nets are, how they apply to a circuit board. We're going to draw tracks onto our PCB to connect the components that we've added, and then we will see how we update the schematic so that the components all have a connection onto a net. From there, the final part will be to rearrange the components so we end up with something that looks just like a schematic. In fact, it is a schematic. Okay, so I hope you enjoyed part 1. Get into the comments below. Let us know what you thought about that, anything that you think we should have covered or maybe have done differently. We can talk about that in part 2. I'd just like to thank PCBWay.com once again for sponsoring this video. Guys, their service is really, really good. If you want to prototype some PCBs or produce some PCBs, give them a try. In the description to this video, you will find a discount code. So if you're setting up a new account with PCBWay, you get $5 off your first order. That means effectively, if you just want to prototype some PCBs similar to the ones that we're making, all you'll pay for on your first order is the postage. And that's an unbeatable deal, guys. So give them a try. I'm sure you will not be disappointed at all. Until part 2 then, on behalf of Detlef and myself, we'd just like to say we hope you enjoyed this video. We certainly enjoyed making it, and we look forward to seeing you again soon on another Learn Electronics Repair video. Ciao for now, guys.